A cutting-edge approach to 3D printing has revolutionized the manufacturing process by seamlessly integrating multiple materials. Greetings, everyone. Today, we are going to delve into an exciting subject: the emergence of an advanced 3D printing technique known as the freeform multi-material assembly process. This cutting-edge method enables the efficient production of complex products such as sensors and circuit boards that consist of multiple materials and layers. By utilizing a machine equipped with 3 specialized nozzles, this innovative process allows for the incorporation of various components, including laser-induced graphene. Supported by the NSF, this groundbreaking approach has the potential to completely transform the realm of product manufacturing, offering advantages such as accelerated prototyping and a reduced ecological footprint. So without any further delay, let us embark on our exploration of this fascinating topic. In a recent publication in Nature Communications, a groundbreaking research paper details an innovative method that combines 3D printing and laser technology to produce sensors, circuit boards, and even electronic textiles with multiple materials and layers. The free-form multi-material assembly process, a groundbreaking innovation, is set to completely transform the way new products are manufactured. Through the utilization of printed sensors integrated into a framework, this machine possesses the capability to fabricate objects that possess the ability to detect and respond to various environmental factors, such as temperature and pressure. This breakthrough opens up possibilities for researchers to create seemingly organic objects like rocks or seashells that can accurately gauge the motion of oceanic waters. Furthermore, this technology holds potential for the development of wearable devices that can continuously monitor vital signs, such as blood pressure, for the general public. In comparison, alternative methods lack the versatility and precision required to match the capabilities of this material in terms of accommodating smaller components within larger 3D structures. The Mizu team has devised a unique approach to address these challenges. Their innovative technique involves the construction of a machine equipped with 3 distinct nozzles. The first nozzle dispenses an ink-like substance, while the second employs a laser to intricately carve shapes and materials. The third nozzle introduces supplementary functional materials, thereby augmenting the capabilities of the end product. The process commences by fabricating a fundamental structure using conventional 3D printing filament, such as polycarbonate, a transparent thermoplastic. Subsequently, the laser is utilized to transform specific components into laser-induced graphene, precisely placing it in the required areas. Ultimately, additional materials are incorporated to enhance the functional prowess of the final creation. The National Science Foundation NSF Advanced Manufacturing Program is generously funding this project, while the NSF I-Core TM program is offering financial support to facilitate the exploration of commercialization opportunities. According to Lin, the I-Core program is playing a crucial role in identifying market demands and interests. While initially targeting researchers, we anticipate that it will eventually prove advantageous for businesses as well. By enabling companies to create prototypes internally, the program significantly reduces the time required for device fabrication. This exclusive technology, currently exclusive to Mizu, holds immense potential for revolutionizing the fabrication and manufacturing processes of various products. According to Bujing Dezheng, the lead author of the study and a doctoral student in mechanical engineering at Mizu, this groundbreaking technique has never been utilized before, opening up a realm of unexplored potential. Expressing enthusiasm for the innovative design, Zheng shares his excitement about the opportunity to embark on a truly unique endeavor at Mizu, fulfilling a lifelong aspiration to pioneer uncharted territory. A significant advantage lies in the fact that innovators are able to concentrate on the creation of novel products, free from concerns regarding the prototyping process. According to Javan Lin, a mechanical and aerospace engineering associate professor at Mizu, the emergence of this technology presents exciting opportunities for the creation of fresh markets. The impact will extend to various industries, including wearable sensors, customizable robots, and medical devices. Presently, the manufacturing of complex structures like printed circuit boards is a laborious and resource-intensive process involving multiple stages and materials. This not only incurs high costs and consumes time, but also contributes to environmental damage through the generation of waste. The inspiration for the new technique not only stems from natural systems, but also offers a more sustainable solution for the planet. According to Jung, all elements found in nature are composed of both structural and functional materials. As an illustration, consider the case of electrical eels, which possess bones and muscles that facilitate their mobility. Additionally, they possess specialized cells capable of emitting up to 500 volts to ward off potential threats. These observations of biological phenomena have served as a source of inspiration for scientists seeking to devise novel techniques for constructing three-dimensional structures with diverse functionalities. However, it is important to note that alternative approaches to fabrication have certain inherent constraints and limitations. To support our channel's growth and ensure broader awareness, kindly hit the like, share, and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.